In this video, we are going to work a couple problems where we are asked to complete the square. So the idea with completing the square is to add whatever constants are necessary to an expression, a quadratic expression, so that we can factor it into a perfect square. Now think about something like this. If I have n minus 1 squared, when I multiply that out, I get the expression n squared minus 2n plus 1. So this expression that I end up with, n squared minus 2n plus 1, can be factored to the perfect square n minus 1. Similar thing we can do with something like n plus 4 squared. When I multiply it out, I get n plus 4 times n plus 4, which results in n squared plus 8n plus 16. Now when you work enough of these, you start to see a pattern. And the pattern is that if I take this b term here, negative 2, and I divide it by 2, the first thing is that's going to give me my factors. Secondly, if I square that term, so negative 1 squared, let me undo that for a second here, equals 1. And that's the constant that's added to the end of my expression. We can do the same thing down here. If I take my b term, 8, and divide it by 2, I get 4. 4 is my factor, and when I square 4, I end up with my expression, my constant that is added to the end of my expression. So when you do a whole bunch of these, you start to see these patterns, and it gives us a method to complete the square. So what I'm going to do for this first one, this is number 2 from the analytic geometry homework, I'm going to take my b term, which is 40, and I'm going to divide it by 2, and I get 20. So since it's a positive 20, I know that my two factors are going to be n plus 20 and n plus 20. But before I can factor that, I need to have this missing expression here. So to do that, I need to take my 20, or this missing constant, I keep saying that wrong. So 20 squared is 400. So I'm going to add 400. Now this is a completed square, which results in the factors n plus 20 times n plus 20, or n plus 20 squared. So let's do another one. That was a nice and pretty one. This one's a little uglier because of the fractions, but it works exactly the same way. My b term is negative 13 over 7, and I'm going to take half of that. So I'm going to multiply it by half. Divide by 2, I get the same expression. So I'm going to get negative 13 fourteenths. So I know this is going to be my factor, so I'm just going to keep it there on the side. But I can't factor it until I've got my constant. So for that, I have to take my negative 13 over 14 and square it, which is going to give me 169 over, I think it's 196, but I'm going to plug it in just to make sure for myself. Yep, over 196. So that's just 13 squared over 14 squared. So now that my square is complete, I can go ahead and write it as a perfect square. So it would be x minus 13 over 14 times x minus 13 over 14, or we can take the shortcut method and just write it as a square. X minus 13 over 14 squared. And that's how you do problems 2 and 9 from the analytic geometry homework.